Today we're going to talk about absolute value real-life application problems. There's two different scenarios that we present. One is when we are looking at products and we are looking for products that fall in the acceptable range, meaning that their tolerances are not too large or too small. The rejected or unaccepted problems, that is where our product is exceeding those standards that are being set. So when we looked at the acceptable products, we're talking about products that are less than or equal to the tolerance, and when they're rejected, they are greater than the tolerance. They're outside the tolerable size or weight or whatever the situation. Notice the two formulas are the same. The only difference is their inequality symbol. So let's take a look at our first word problem. This one pertains to the size, in particular the circumference of a woman's basketball. It must be between 28.5 inches to 29.0 inches. So which absolute value inequality best represents the circumference of the ball? So I like to think of this on a number line. If we have 28.5 is the low within tolerance, and 29.0 to mean the maximum of the tolerance, the average is falling somewhere in the middle. So let's find the average. 28.5 plus 29.0, we're going to divide that by 2. And that gives us an average basketball size for a woman of 28.75. Okay, so if you recall the absolute value formula, if you will, it talked about the absolute value of the circumference of a particular given ball minus the average of 28.75. And then we need to decide what the tolerance is. Well, the tolerance is nothing more than if we take our average, we're going to subtract it from the high, and we get 0.25. And if we take our tolerance, our average tolerance, and subtract it from our low, we also get 0.25. So right in the middle, this is our average of 28.75. Again, the difference between the sizes, this one, the tolerance is higher by 0.25. This one is lower also by 0.25. So we're going to pick the scenario that best fits. Obviously the tolerance is not either side of the basketball. That doesn't make sense. We're going to eliminate those two answer choices. Also, this is an and scenario. We talked about that before when we talked about equal or than, equal to or greater than signs are or problems, and less than signs are and problems. So being that this has to fall between 28.5 and 29, that's an and scenario. So this inequality symbol simply does not fit. So our answer choice is C. Let's take a look at another problem. The weights of 12 packs of potatoes range from 14.75 pounds to 15.15. Now the fact that there's 12 sacks of potatoes really doesn't make a difference. We're going to look at the average because they didn't provide that in this problem as well. So we're going to add the two weights together and divide by 2 to get the average. And our average ends up being 14.95 is our average. So we know a particular package of potatoes or sack of potatoes, we're going to take the absolute value of that particular sack minus the average, 14.95. And we can see all the answer choices are 0.2 as far as the tolerance, because once again, if we take 14.95 and subtract 14.75, we get 0.2. And if we take 15.15 and subtract the average, we also get 0.2. So we know that's our tolerance. Again, we're looking at they're in the acceptable range, so this inequality would also be a less than or equal to. And this would be our answer choice right here. Make sure you pay attention to the signs involved as well as what they're using for the average and what they use for the tolerance. Now we have another problem, and this is sometimes typical of some of these problems because it provides us with the tolerance and it gives us the average amount. So it says to write and solve an absolute value inequality that describes acceptable volumes, and that's the key word that we need to look for here. We're looking for acceptable. So being acceptable, we know we have our product. Let's say bottle of salad dressing. Let's use D for dressing, minus the average amount. In this case, it's 16. We know the tolerance is 0.6. And being acceptable, remember, that means less than or equal to. So if we solve each scenario, remember we isolate the absolute value sign, set up our first problem as is, and this isn't less than, so it's an and problem. D minus 16. Don't forget to flip the sign, and we're going to negate. Now we can solve each. So we're going to add 16 to both sides. And we get this bottle of dressing can be less than or equal to 16.6, the maximum size that's acceptable. Working our second problem, D is greater than or equal to 15.4. Again, if we were to put this on a number line, the small number is on the left, our larger number is on the right, the size of our dressing bottle ranges between, and it can be greater than or equal to 15.4 or less than or equal to 16.6. So this would be the outcome for the acceptable range for that bottle of dressing. Our next problem is the city ordinance states that pools must be closed by a fence that is from 3 to 6 feet high. 3 feet to 6 feet high. Right, an absolute value inequality describing fences that don't meet this ordinance. So we're talking about a rejection problem here. If they don't meet the ordinance, that means they're being rejected. So what do we have? We don't have our average. We just know that they fall between 3 and 6. And we're going to divide that by 2. And so our average height of the fence for a pool is 4.5 feet. Our absolute value then of the fence minus the average measure of 4.5 feet. And now this time we're talking about rejection. It would fall greater than the tolerance. And what would the tolerance be? Well, that would be the difference between 6 and 4.5 or 4.5 and 3. So that would be 1.5 feet. Okay? Write an absolute value inequality describing fences that don't meet this ordinance. It didn't say to solve, it just asked us to write the inequality statement. Rejection is greater than. Just like our other videos, if you have any questions, feel free to rewind it, play it over again, or if you would like, come into CAB Morning. We'd be glad to help you.